Let us consider an example to calculate the current through 8 ohms resistance. What is the numerical problem is, using Norton's theorem, find the current in 8 ohms resistance for the network shown below. The network is like that, 40 volts and 4 ohms, 5 ohms, 6 ohms and 8 ohm. We have to calculate the current through 8 ohms resistance by using Norton's theorem. What are the steps to be followed is, step 1 is to find current, Norton's current. We have to short circuit the 8 ohms resistance that acts as load. The A-B terminals are short circuited, we can see. The resistance RL is removed and the terminals AB is shorted. The current through AB is Norton's current. For this circuit, if you short like that, the equivalent circuit, equivalent resistance becomes, it is in series with the parallel combination of this. These are in parallel, 5 ohm and 6 ohm. Suppose the I dash is the current coming, after that it is dividing. R equivalent is, now what is the R equivalent? 4 plus 5 ohm and 6 ohm is in parallel. Because we have to calculate Norton's current. Norton's current in the sense a current I equal to V by R according to Ohm's law. 4 plus 5 into 6 by 5 plus 6. It is the parallel combination of resistances. It is the parallel combination. Hence we are using equivalent resistance in parallel. 5 into 6 by 5 plus 6. 4 plus this one gives 6.27 ohm. This is the total resistance on the load. Now I equal to V by R. I dash. I assume that the current coming from 40 volts is 40 by 6.27. This is the load resistance, total resistance 40 by 6.27. How it is possible? By using Ohm's law. I equal to V by R. V by R. V is 40 volts and 6.27, 5.94 amperes. That is the total current coming from source. That is source current it is. What is the load on the source is total equivalent resistance 6.27. Now Norton's current is given by total current into Norton's current is 5 ohms lo poye current. What is the current flow is in 5 ohms resistance? It is called as Norton's current or short circuit lo poye current. ఇక్కడ షార్ట్ సర్క్యూట్ చేసాం కదా, ఇక్కడ పోయే కరెంట్ అంతా కలిపి నార్టన్స్ కరెంట్ అంటున్నాం. ఎందుకంటే ఇక్కడ కనుక్కోవాలి కాబట్టి మనం కరెంటు. నార్టన్స్ కరెంట్ IN ఈక్వల్ టు I డాష్ అంటే టోటల్ కరెంట్ I డాష్ into opposite resistance 5 ohm. What is the opposite resistance? 6 ohm. Opposite resistance by total resistance 5 plus 6, where we want to calculate. That is the current division rule. We use it in superposition theorem also, the current division rule. Based on that, Norton's current is given by total current into opposite resistance by total resistance. 5.94 we calculated as source current. 5.94 we calculated as source current. By using current division rule, IN equal to I dash into opposite resistance by total resistance. 5.94 into 6 by opposite resistance for this 5 ohms is 6 ohm. Because 5 ohm may be the total resistance of this branch is 5 ohm. Because it's a short circuit. Opposite, it is the current is sharing by 2. Suppose I is entering here, after that it is dividing. For 5 ohms resistance, it is the opponent. Because these two are sharing. The opponent is 6 ohm. Now opposite resistance is 6 ohm by total resistance, that gives 3.24 amperes. This is the Norton's current, and we have to calculate Thevenin's resistance. Ela calculate chesamo, Norton's resistance also we have to calculate by short circuiting the voltage source. Let us see that. Now to find Norton's resistance, the load 8 ohm is removed and battery replaced by short circuit. Voltage source will be short circuited. If a battery or voltage source having internal resistance, we have to represent internal resistance. Because since they are not given any internal resistance, now simply we short it. After seeing that terminals A and B, we have to calculate what is the total. From here onwards we have to see. That is A and B terminal, the direction is indicated. ఇక్కడ నుంచి చూసి మనం ఈక్వలెంట్ రెసిస్టెన్స్ కనుక్కోవాలి. దట్ ఈస్ నోన్ యాజ్ నార్టన్స్ రెసిస్టెన్స్. Now by seeing this, these two are in parallel and it is in series with this. And 5 ohm is in series with parallel combination of 4 and 6. Now 5 ohm plus 4 and 6 parallel combination. 4 is parallel with 6 ohm. That is 5 plus 4 into 6 by 4 plus 6. That is the equivalent resistance R1 R2 by R1 plus R2. That is 7.4 ohm. Now draw the equivalent circuit in third step. After that we can calculate what is the current through 8 ohms resistance. Now we draw the equivalent circuit. IN is parallel with resistance and a load resistance. In is 3.24 we calculated and Rn is 7.4 we calculated. Now current through 8 ohms resistance we have to calculate, that is 8 ohm. Current in 8 ohms resistance equal to In. In is, this is the current In is coming up to this side. After that it is moving. Current through 8 ohms is given by total current into opposite resistance by total resistance. Similarly, current in 8 ohm resistance is, current is dividing here. Total current In into opposite resistance divided by total resistance. 3.24 into 7.4 by 8 plus 7.4. Similarly, what current division rule we apply. After that 1.55 ampere is current through 8 ohm. In this manner, we have to calculate the current through various branches, various resistances by using Norton's theorem. What are the steps to be followed? Starting we discussed about what is Norton's theorem. Any circuit can be converted into a simple circuit, that is Norton's current source is in parallel with Norton's resistance and resistance, load resistance. This is the circuit we given. We converted this circuit into Norton's current we are calculating. Now by short circuiting 8 ohms wherever we want to calculate. After that, in second step, by open circuiting this, and voltage sources will be replaced by its internal resistance. If the voltage source is there, it will be short circuited. If any current source is there, it will be open circuited. After that we calculated Norton's resistance similar to Thevenin's resistance. Similar Thevenin's theorem lo ela aithe kanukunnaro Thevenin same alage kanukoవాలి. After that equivalent circuit draw chesi manam current find out chesam. Ikkada current division rule we are using. Current division rule says that total current through any branch or any resistance is equal to total current into, total current here is In into opposite of that resistance is opposite resistance by total resistance of Rn plus RL, that we used.